Have you ever wondered if the Earth is spherical or not? Well, the answer is kind of both. To understand this concept, we have to travel back 4.5 billion years in time when the Earth was about to form. I think most of you know what formed the Earth and other planets. It's gravity. Basically, gravity acts like a cloth or a fabric that is wrapped and curved with a distribution of mass and energy in it. So let's dive more into what that means. This is the space-time. And it's not flat because there is no mass and energy that can interact with it. But once there is mass, space and time is curved. But what does that have to do with the Earth? Well, at the beginning of its formation, a combination of dust and rocks collided with each other, invoking space-time to curve. And this curvature attracted other heavier objects that made space-time to curve even more, which formed the Earth we know today. And because of the way how the Earth was formed, it now has an angular momentum that contributes to its spin. And that spin is what gave it the non-spherical shape. As the Earth spins, it bulges from the sides. The reason for that is the centripetal force. In other words, the faster it spins, the centripetal force increases with radius. That leads to its equatorial bulge, since velocity is directly proportional to the radius. Another reason for its bulge is the tidal forces acting on it from the sun and the moon. If you are not familiar with it, the tidal force is a gravitational effect that stretches the body towards it. Imagine that this ball is the Earth and the camera is the moon. Due to the gravitational effects caused on the Earth by the moon will try to attract the nearest side of the Earth towards it, almost stretching it out like this, creating a bulge. In fact, we do have two types of tides. There is a spring tide that is the strongest and is usually caused when the moon is aligned with the sun. At this point, the Earth is at its most bulge because the effects from the sun and the moon add to each other. On the other hand, there is a neap tide that is the weakest and is caused when the sun is at 90 degrees. Thus, they cancel each other out, giving a smaller bulge. So now we can conclude that the farther the planet is, the less bulge it will have. This is valid because if the Earth was the sixth planet with the same rate of rotation, it would bulge less due to the decreased tidal forces acting on it from the sun. And now you might also say that the other 5 planets in our solar system, such as Mars, Jupiter, Saturn, Uranus, and Neptune, bulge less. Wrong. It is true that the tidal forces acting on Saturn are less, but because Saturn completes one rotational period every 0.45 days, which is really fast, it is able to bulge more than expected. Saturn has the greatest bulge and the fastest spin of all planets in our solar system. So before judging on how big the bulge is, the centripetal force and tidal forces have to be considered. Now you're pretty confident that most planets in our universe are not perfectly spherical. But cosmologically speaking, we do have a spherical Earth, because if it didn't have a spin or any tidal forces acting on it, then in this case you might say that Earth is perfectly spherical.